Hello students. In before lecture, we have studied a few points of our unit number 1. Okay, so remaining point, today we are going to discuss the remaining point, which is going to be our entire remaining part of our unit number 1. Okay, so the points to be covered in this video are the important point is architectural design for Ubicom systems. In that we have a 4 points which is pretty much important to understand what is the inside of ubiquitous computing, which is pretty much important topic to understand what is what is the ubiquitous computing. Okay, so here architectural design for Ubicom systems. Okay, in our previous video I have mentioned the smart DI model, and today we are going to learn it this smart DI model in detail. Then we have a smart devices and services, then service architectural models, different models that we have, and the next one is service provision lifecycle. Okay, so we start our video with our first point, which is the smart DEI model. As you all guys know, what is the smart DEI, which is a smart devices, smart environment, and smart interaction. I have mentioned one diagram here. Okay, the device trends. What kind of a device trends that we got? Here is the first section. This entire section is for smart devices. This section is for smart environment, and this section is for smarter interaction. Okay, so in the first section we I have mentioned in the first section mention they use more complex and multifunctional mobile personalized devices. You guys all know the what kind of devices that we have. They are complex, they are multifunctional, and they are personally the mobile. That's what we called a mobile. Okay, then we personalize, we can do the any stuff that we want on the on our mobile. Okay, so this is the things, and the important part is increasing capability to manufacture low power, micro, and more complex devices. Okay, we have a smart devices which are pretty much a micro. We got a good size of devices that we got. We will see in our in this video what kind of devices that we made and what kind of devices that we relate to that particular stuff. Okay, so second point is going to be the smart environment. What is the environment? For example, walls can sense camera is recording and modify lighting to improve recording. Okay, which means that sometimes you record something, sometimes you record some scene for your video or for your movie. So what happens in the smart environment, the walls, actually the walls that the main they have at a physically, they can sense what kind of lights are coming, and based on that what kind of scenes will be coming and what kind of a recording that we are going to do. Based on that it will do the recording. And third one is just smart interaction. What is interaction? There I have mentioned the example. Camera can interconnect to phone to share recordings, direct to printer to print. This is the smarter interactions. You guys connect your mobile to the printer, you guys connect your mobile to the AC, you can connect your mobile to the fridge also. So this is the interaction between the smart DI model, and smart DI model is nothing but the interaction between the three stuffs, which is devices, environment, and interaction, which is a smart. It is also important, so keep these things in mind. Whenever you will get this concept, you just go through this diagram, you will get the entire result. Again, what the model says, what the model here are different smart devices, smart environment, and smart interaction. And smart devices, we have services. For services contains the data and task, mobile content, pad and type. We will see this in one by one on our further videos. So just for now, just understand the smart devices, what kind of elements that they are connect to that particular smart devices, which are this VB virtual machines that have uh, multitask operating system that we have. Then smart environment, this is the things that connect with it. We will see the important things from the smart DI model in our further lecture. Okay, then smart interaction, that we have this kind of interactions, multi-agent, this is the knowledge is there. This is the all the important stuff to make interaction a smart. That's the meaning of this model. But it is, again I'm going to say you is that this is a pretty much important diagram. as your academics concern. Also in general, you got if you want to get the knowledge to the smart DI, you will get this. Okay, now we will see some small theory points regarding it. I don't think it much like it contains the rocket science, but what does the smart devices? The second point I have mentioned here, the main characteristics of a smart devices are mobility, dynamic service discovery, and intermittent resource access, which means the concurrency, upgrading. For example, I'm giving you the example of a database. Sometimes what happens, you go to the ATM at the same moment, um, you from your account the money has been withdrawn. At the same moment, your parents go to withdraw the money from your account from the bank. At the same moment, you withdraw the money from the ATM. So at the moment, the concurrent access will be there, and at the same moment, the transaction must be reflected in your account. So that stuff, that relation must be implemented in the smart devices. Concurrency is pretty much important in every aspect. Then we have again a few points which is contain the smart devices. First point is Vizor's ICT device forms, which contains the tabs, which contains the pads, and which contains the boards. We will see this. What does the tabs? We all know the tabs. We all know the boards, smarter boards that we have. Okay. Computer-based devices tend to become smaller and lighter, in which cheaper to produce. Thus, devices can become prevalent, made more portable, and can appear less obtrusive, which is an important thing. Okay, as we all as our technology is growing, we will see that the device sizes will be less, and they are more interactive, they are more intelligent than the previous one. So that's the model. That's the model is said by the Vizors to contain the ICT device form. Some are contain some are from the tabs, some are pads, and some are boards. Okay, then Bezos consider a range of devices sizes in its early work, from wearable centimeter sized devices, mostly the tabs are centimeter size, to handheld decimeter sized devices like pads, and then meter sized like boards. Like the smarter boards, some people are used to told the people's told to or to give a kind of a problem solving, and any kind of stuff that we are done on the physical um, blackboard. So that kind of boards are there. Okay, so this is the first point. Then second point is extended forms for ICT devices like dust, skin, and clay. We are aware about the tabs, pads, and boards. Okay, so based on that, what kind of extended forms are there? For the first system, dust. What does dust means? It is a very like the normal dust that we are when in our home, like at based on that, like that kind of a dust, which means it contains that kind of a size of that device which is looks like a dust, but it is a far more intelligent devices. Like ICT devices can be like MEMS, which means that micro electromechanical systems ranging from nanometers through micrometers to millimeters, which means that how you will understand that nanometers very much, it likes negligible to see. That kind of devices are made, and we called it as dust, which is a smart dust. Okay. Then second form is skin. What does the skin? Okay, you see the second definition, you see the second explanation about the smart dust, which means that you have a surfaces, and based on that surfaces you just put on some kind of a sensor which gives you the information to work on the devices. So this called the skins, which means that there is a part, and on that part you just put the small skins. Like our human body, we need to sense. For example, you need some what, which means that if you touch to the heated iron, you will get that kind of a reaction in your body. So that kind of a skins, that which is called a skin, which is reactable, which is give you kind of a, like touch screen is also the smart skin. Touch screen contains the small parts of a different smart skins to make the things happen. And third one is a smartly. It is in ensembles of MEMS can be formed into arbitrary three-dimensional shapes as artifacts resembling many different kinds of physical objects, which means that smart clay contains the dimensional view, which means that sometimes what happens, you got a view which is not going to be what should I say, it is not going to be easily seen. Okay, so based on that, the smart clay will contain the small parts which is based on or physical object based on the dimensional shapes, which is important. Let's see the third points, which is regarding to the smart devices, is mobility. And the mobility has a different uh, properties. First is accompanied, second is a portable, third one is a handheld. What does the accompanied means? It these devices that are non-worn or implanted, which means they can either be portable or handled, or okay, either be portable or handled, or which means that they are one of them, which is a portable or handled, separate from carried in clothes or fashion accessories like we all did with our mobile. Okay, then second is a portable, like laptop computers, which are oriented to two-handed operations while seated. Mobile, we have sometimes what happens, we handle the mobile in single hand, so this is the portable. Then the handheld, you will like devices are usually operated on one-handed and on occasion hands-free, which is also, which means you give the instruction through your through the voice through the voice search. So like this is has to be done with the mobility. Then fourth one is a handheld, and the five one is implanted or embedded, which means that these are heart pacemaker. They may also be used to enhance the abilities of physically and mentally able humans. This is the thing. Then we have a smart environment. We have in our smart environment, we have a different important things. To make the environment smart, we needed to do this highlighted points as our key techniques. First is tagging and annotating the physical objects. Sometimes if you use the Google Maps, and you will see that sometimes there will be a RFID tags are put there to the particular locations, like there is a temple, there is a petrol pump. To understand that, their tag are must be there to understand. If there is a no tag, you will not understand what is there actually. If you want to find the ATM, you can find on the route, but if you put the tag here, it is easily understandable to the user. So tagging and annotating is a must in the physical environment. Then sensing or monitoring the physical environment. Transducer, it is pretty much physical object which is highly intelligent from the physical environment to convert some phenomena in the physical world into electrical signal that can be digitized, which means that transducer has a work to contain the physical world electrical signals that can be digitized. So this is a transducers. Then we have filtering, again, to make the things happen in the good way in the smart environment. We need a filter. A system forms an abstract or virtual view of part of its environment, such as the physical world. Then we have adapt, again, to here we need to specify the context where we are going to put those things on the smart environment, which is the adapting, which means that it adapt the changes in the environment. Like physical environment route is based upon the relation of a current location to the destination location, which means that sometimes we got a turn on the in the physical world, the Google Maps must show the turn on the virtual view also. This is kind of adapting that we have. Then again, the controlling the physical world, like for example, I have said in our previous lecture also, sometimes what happens, you made the sensor which is going to give you the exact level of the water. If the overflow is occur, it will give you the alarm. So based on that, this is kind of a controlling the physical world. It will give you, sometimes if you give the option to the robot, is that just stop the water flow based on the signal that you receive. So this is kind of a thing in the smart environment must be done. Then we have second point regarding to the smart environment is that embedded versus untethered. Okay, firstly we understand that what does the tagging, what does the sensing that there, and they have a five different points which is important to the smart environment. Then the B and the important point is embedded versus untethered. Embedded means, which means that provide control and sensing support to a larger system, and embedded devices are statics that are embodied in a large system that may be static or mobile, which means that a sensor, sometimes the sensor, if you make the robot, you need to put a different sensor into the robot body to understand what's happening, to understand where to go, what did the robot will do in the situations like these things will happen with the sensor. This is called embedded. And untethered means spray devices that can be mixed with other particles and spread onto the surfaces. As I have explained earlier, the example of a smart dust, which is a perfect example of untethered. You just what should I say, sprayed onto the particular surfaces to understand what kind of a surfaces, to understand what the surface will do on the particular basic what should I say, basic operation. Also, this is the second point, which is untethered. Then we have a device sizes, which is the important thing in the smart for the smart environment. When you done the things, but you also understand what kind of a sizes that if you put like in the centimeter sizes, which is a bar in the foods or all those things, but this is not going to be acceptable if you make as small as possible, like MEMS devices, micro electromechanical type devices, then it would be acceptable. That's what kind of that's kind of explanation I have put here. Macro size devices are range of device sizes from the tab sizes devices through pad sizes to the board sizes that we have already explained. Then we have a smart interaction. Okay, what kind of the interaction must be smart based on the different. Firstly, we need we understand the basic interactions. We all know this synchronous interaction and asynchronous interaction. This concept is similar as the networking, like synchronous communication and asynchronous communication. Exactly the same communication, exactly the same interactions would be happen here. Synchronous means based on the you read the entire definition, but I will give you the uh, contextual based things using the example. A client component makes a request to server component and gets a response, which means that if you make a request, you will get the response. If you make a request and request again and again, and if you wouldn't get any kind of a responses back from the server, then there is a not, this is not kind of a synchronous interactions that you make. Synchronous means you both have kind of a natural understanding, you kind of understanding between the two devices, and based on that the synchronous interactions would be happen. Then second point is asynchronous interaction. The interaction protocol consists of a single messages that have no control of flow. As I have said before, synchronous interaction, asynchronous, it is a vice versa of that, which means that an error message is generated, but it is not clear if the error will be handled, leading to response messages. As I said before, if you make the request and again and if you wouldn't get any kind of responses from the server that time, you get stuck in the confusion, like what happens with your system. If there is an error, if there is a successful transmission of things, you will not get any kind of a message from the server. So this is the awesome, this is the basic interaction. If you make the system like smart interactions, you need to understand, you need to consider these basic interaction points. Then secondly, we have some advanced points regarding to that. First is coordinated interaction. Different components act together to achieve a common goal. Again, I'm going again, this point comes when you make the smart devices, you need to understand the holistic framework that I have explained in the unit number 1 in our lecture number 1, which have the video which I have uploaded early. If you haven't checked, I will give you the link in the description. You just check this out, that lecture first, and then come to this lecture. Okay, so coordinated interaction, which means there are, if you make the mobile devices, you need a different small devices to understand the things, and the base and the most important things, the coordination between that sensors or the particles that you using. If you don't put any kind of a coordinations, you will not get any kind of a smart interaction related to that. The second is the policy and convention based interaction. Different components act together to achieve a common organizational goal, but it is based upon agreed rules. This is contractual policies without necessarily requiring significant explicit communication protocols between them. Like you need to policy in the sense that the logic you used to work them to work to what should I say, the you make a kind of operation between two, this kind of called a policy. If you have a, if you put some kind of a work between two, so they, these two applications, these two things must done those things also. They do not overbreak, they do not abuses, I'm not saying abuses, but they do not break the policy. Then third one is a dynamic organizational interaction. Like organizations are the system which are arrangement of relationship but with intelligence, so that the produce a system with qualities not present at the level of individual.